Hello, so today I'm going to be talking about Fundamental Theorem of Calculus, Part 1. Get all pretty. Okay, so to start off, we're going to have a graph, and it's going to have a function on it, right? And we have y-axis, and then t, and the function is going to be y equals f of t. Next, we're going to have two lines on the graph, 2 points, a and b, and f is going to be continuous from a to b. Then next we're going to add another point, which is going to be x. And that's what we're going to use. So what we're going to be trying to find is the area under the graph from a to x. So what is that? So we can kind of write this out by saying f of x equals the definite integral from a to x of the function f of t dt. So what do each of these things mean? That big S thing is the definite integral. That's going to be the area under the curve. So you can also see that in the pink of our graph. And then along with that, x and a, that's going to mean from a to x. And then f of t is going to be our function. So for the function f of t. So how does this relate to the fundamental theorem of calculus part 1? Basically, if you take the derivative of the integral, you're going to get the function back. So this kind of relates integrals and functions. So if we're going to take the derivative of what we just found, we are going to get f of x. So we can write out what we just had, take the derivative of both sides, and that is going to equal the function, f of x. You can see that on the graph too. So the derivative of that area under the curve, and that is going to be equal to f of t, which is our function. So let's do some problems. We're going to find this. The first one, from 1 to x, and then our function is going to be 2 plus t to the 4th to the 5th. So we're going to do pretty simple. We're just going to plug in the x for the t. So we're going to get 2 plus now x to the 4th, and then all that to the 5th. And that is your answer. Super simple, just plugging the x in when the x is on the top. We can do it again for this one. We have from 4 to x, the definite integral of the function cosine t dt. Again, we are just going to plug in that x for the t, so it's just going to be cosine x. So yeah, these are super simple, very simple, and fun. Easy. But what are we going to do if the x is on the bottom and we have a constant on the top or a number on the top? And what is that going to look like? That is going to be if, just like that, x on the bottom, 4 on the top. So let's do a few examples of those. So we have g of x equals definite integral from x to 1 of 1 over t cubed plus 1 dt. So what are we going to do? First thing, we're going to do a little switcheroo of the top and the bottom. Bring the x to the top, bring the 1 to the bottom. And right after we do that, we have to make it negative. As you see, negative sign highlighted by the green, very important to switch the sign. So now we're going to have the x on the top, 1 on the bottom, and then just the same function we had before. So now that we have the x on the top, we can plug it in, just like we've been plugging in the x before. So it's going to be negative 1 over x cubed plus 1, and that is our answer. It should be number 4, but it's number 5. So what are we going to do now that there's an x cubed? So if we have an x cubed, we're going to use chain rule. So how do we do that? We are going to find f prime. We're going to plug in that x cubed, but then we're also going to have to multiply it by the derivative because that's chain rule. So it's going to be really simple. Cosine x cubed times 3x squared, and you can just bring that 3x squared to the front for your answer. Here's another one with an exponent on the top. So we're going to plug in again that x squared, or whatever the x is for the t, and then we're going to multiply it by the derivative for chain rule. So it's just going to be 2x times square root of x squared plus 1. And that's using chain rule too. This one we're going to go a little bit slower because we're going to use both things we just learned, and it's a little bit more difficult. But as you can see, our x is on the bottom, along with the fact that it has a exponent at x squared, so we're going to have to be using chain rule. First thing we're going to do is we're going to flip the 2, add a negative sign, so it's going to be 1 over x squared on the top, 0 on the bottom with a negative sign, and then we're just going to keep the same function that we had before, dt. Okay, good. Now what are we going to do? Plug in that top value like we always have been doing. Plug that into the t's. So then what we're going to end up getting is y prime equals negative 1 over x squared plus 1 over x squared squared. Now, we do have to use chain rule for this, since we have to take the derivative of x squared, 1 over x squared. So what is the derivative of 1 over x squared? We're going to do it up in the corner here. It's going to be 1 times x to the negative 2, so we can bring that exponent to the top. Then use product rule, so it's going to be negative 2x, negative 2 minus 1, negative 3. So that is going to be our derivative, and we're going to multiply that in for the chain rule. So now we have that, we can simplify the equation here. And then we're going to simplify the other one too. We're going to fix it up, bring that x to the bottom. Now we can bring that 2 over x cubed to the front. The negatives cancel out, so this is going to be a positive. We can distribute that. It's going to be 2x squared over x cubed plus 2x to the fourth over x cubed. Simplify that, we're going to get 2 over x plus 2x, and that is your answer. So when we are applying the fundamental theorem of calculus part 1, if the x is on the top, we're going to plug in that x for t. If we have something like x squared, we're going to plug in that x squared while applying the chain rule, so we're going to multiply by the derivative. And if it's on the bottom, we're going to flip, add a negative, and along with this one, because it's an x cubed, we will be applying the chain rule again. So just remember that. So next up, you will learn Fundamental Theorem of Calculus Part 2. Thanks for watching!